Hello students, welcome to Narayan PU College online classes. So we have completed 3 chapters in chemistry. One is solutions, haloalkanes, haloarenes, alcohol, phenols and ethers. And coming to the competitive, and 2 chapters, those are solutions and alcohol, phenols, ethers have completed. Now one pending is there, competitive, haloalkanes and haloarenes. That we do in this class. Yeah, and see that here your competitive book, page number 98, level 1. Level 1, page number 98. Okay. See the question here. First question: ethyl bromide can be converted into ethyl alcohol. Ethyl bromide. You know what is the formula of ethyl bromide? C2H5Br. Ethyl bromide should be converted into ethyl alcohol. What is the formula of ethyl alcohol? C2H5OH. This is. So they are asking how to convert ethyl bromide into ethyl alcohols. Options they have given. The first one is heating with dilute hydrochloric acid and zinc. The first one, C2H5Br ethyl bromide treated with zinc and they have given hydrochloric acid, Zn plus HCl. As I already mentioned, and whenever metal and HCl, then this reagent, this act as a reducing agent. This act as a which one here? Reducing agent. When it acts as a reducing agent, and it reduces the ethyl bromide into ethane. So that's why you will get the compound here is C2H6. But what we want here? We need here C2H5OH. So first option is not correct. And second one, boiling with alcoholic solution of KOH. You already know ethyl bromide CH3CH2Br and treated with alcoholic KOH. And you know alcoholic KOH, whenever alkyl halides treated with alcoholic KOH, which one it is? It acts as a base, so that's why elimination reaction. So we have already discussed CH2 plus what you will get here, KBr, elimination. So this is also not the option. Next one is action of moist silver oxide and CH3CH2Br. You know, and they have given here silver oxide and moist. And you know that silver oxide and moist means you already know, we have discussed Az2O. Moist means what we have to take? H2. Then what the product you will get here? AzOH. 2 times and here AzOH. Clear? And 2 Az and 2 oxygens and 2 hydrogens and 2 AzOH. And whenever you know ethyl bromide CH3CH2Br and it is what it is, Ag2O moist means it is a silver hydroxide. So that's why whenever treated with aqueous AzOH, then what the product you will get? And bromine will be replaced by which one? OH and AzBr will be. So you will get CH3CH2OH plus what you will get? AzBr. So next one. And reflexing with methanol reflexing, you will get the ethers line. So that's why, and first option is wrong because you are getting C2H6 and alcoholic KOH means which reaction takes place here? Elimination. I already mentioned whenever alkyl halides treated with aqueous KOH, substitution reaction. Alcoholic KOH, elimination reaction. And moist Ag2O means you will get the silver hydroxide. Whenever alkyl halides treated with the silver hydroxide, and you know the products are alcohol. So that's why your option 3 is the correct one. Yeah? And coming to the second question, see what the question they have given. Reaction of ethyl chloride with sodium leaves. Reaction of ethyl chloride. What is the ethyl chloride formula? And that's now only we have discussed. This is CH3CH2Cl is ethyl chloride and which is treated with sodium. Which is treated with sodium. Clear? And have you remembered this one? Alkyl halides and sodium. What is the reaction there? Wood reaction. And actually they have given here dry ether, they have not And no problem, whenever alkyl halide treated with the sodium, then you know that it is a Woods reaction. What is the reaction here? Woods reaction. So you know that in the Woods reaction, what are the products we will get? We will get the products are alkanes. How many alkanes means how many moles we have to take here? 2 moles of alkyl halides and 2 moles of sodium. Then what we will get here? 2 Na and 2 Cl will be removed as a 2 NaCl. Removed as which one? 2 NaCl. Next, what is left here? 2 moles of CH3, CH2 will be left. Means what I can write here? CH3, CH2, CH2, CH. This is. And you know that what is the name of this compound? Butane. Clear? And you know in the Woods reaction, alkyl halides are converted into alkanes with the double number of carbon atoms. How many carbon atoms are there here? 2. But here in the product, how many carbon atoms are there? 4. So that is your option is N-butane. Clear? See the what is the option here? Option 3 is N-butane. Option 3 is the correct one here. Clear? And next one. Coming to the question 3. And treated of ammonia with excess of ethyl chloride will yield. You know that ethyl chloride. Ethyl chloride means what is the formula? C2H5Cl, same only. Ethyl chloride and treated with excess of ammonia. Ammonia they have given here NH3, but which one they have taken excess amount here? And C2H5Cl is a excess amount. This is excess amount. So what is the final product they are asking? So we have already discussed in the PU part only. So whenever ethyl chloride is treated with ammonia, what is the product you will get? You will get the primary amides. 1 chlorine and 1 H will be removed as a HCl. Then what the product you will get? C6H5 NH2. Clear? 1 H here and 1 Cl will be removed as a HCl. Clear? This is the product. But what they have mentioned here, excess of ethyl chloride. Excess of ethyl chloride means again it will react with the C2H5Cl. Again it reacted with the primary amide. What is formed here? Clear? Then what happens? Same reaction takes place. Here 1 chlorine and here 1 hydrogen will be removed as a HCl. C2H5 will be added. You see C2H5 and you know N here. 1 H and 1 Cl will be removed as a HCl. Then what we will get? NH already is there. 1 H will be removed and 1 H will be left here. C2H5. Clear? What we will call this is diethyl amide. What is the name of this compound? Diethyl amide. Clear? And again, you know we have taken excess amount here. And again it will react with the, because here hydrogen atoms are there. All hydrogen atoms should be replaced by the, you know, ethyl groups. Then what the compound we will get? Again C2H5Cl, 1 hydrogen and 1 chlorine will be removed as a which one here? HCl will be removed. Then C2H5 will be attached to, you know, nitrogen, and you will get the compound is C2H5, and here also what you will get? C2H5. So how many ethyl groups are there here? 3 ethyl. So triethyl amide. What is the name of this compound? Triethyl amide. And again, is there any chance to react with the ethyl chloride? Because you know 3 hydrogen atoms are replaced by 3 ethyl groups. Is there any chance? Yes. Again, you know here CH3, CH2, Cl. But you know that here nitrogen is having one pair. So that's why nitrogen it donates the pair of electrons to the carbon. You know carbon is having how many bonds here? 4 bonds, and these 2 and 2 bonds with the hydrogen, and the nitrogen is donating 2 electrons to carbon to make a bond. So carbon will have how many bonds here? 5, but carbon should form how many bonds? 4. So that's why. And this bond it will break, because you know chlorine is a very good leaving group. Whenever nitrogen wants to make a bond with the carbon, and chlorine will be removed. So what the product you will get here? You will get the product is C2H5, already nitrogen, and C2H5. 3 C2H5s are there here. C2H5. Clear, madam? Now nitrogen is making a bond with another C2H5 here. You will get CH2. Directly I am writing C2H5. But nitrogen is losing electron here. Losing electron means which charge here? Positive charge, because it is donating electron. positive charge. And here which one is there here? Cl minus. Clear? So what it is here? Tetraethyl ammonium chloride. So how many groups are there here? 4 groups are there. Which groups those are? Ethyl groups. Tetraethyl. Nitrogen having which charge? Positive. Positive means we have to pronounce onium. So that's why tetraethyl ammonium chloride. That is your answer. So that's why you know that in the competitive examination they will simply give when NH3 and excess amount of the C2H5Cl treated, how many moles of C2H5Cl will be used? How many moles used here? 1, 2, 3 and here 4. So total how many moles are used here? 4. But option is here tetraethyl ammonium chloride. Option 3 is the next one is question number 4. See, they have given here chloroform oxygen and you will get here COCl2 plus 2HCl, and they have given on the arrow X. Means conditions you have to write. On which condition and which conditions and chloroform will be converted into phosgene. What is the name of this compound here? Phosgene. This is gas here and can also be called as carbonate chloride. Carbonate chloride. So this is, you know, phosgene and tear gas, and these gases are used in the World War I. Clear? So here, what conditions we have to maintain to prepare the phosgene from the chloroform? And I have already discussed in the PU part. So what is the conditions you have to use here? You see here in this case, and light and A. Means you have to put here HNU and another one is what it is A. Just you need not to maintain any drastic conditions here, and simply and take the chloroform and oxygen and put this reaction mixture in presence of light, and also A, then automatically chloroform is converted into phosgene. So that's why your option is option 3. And the next one, 5th question, direct one. You see, phosgene is the common name for, I already mentioned, COCl2 is called as a phosgene. What is the common name here? Carbonate chloride. So that your option is option 3 is the correct one. And next one, coming to the question number 6. When chloroform is treated with amine and KOH, we get, this is important, and we know one reaction is there, it is not covered in the haloalkanes and haloarenes, because, and this reaction will come in the next chapter, that is amines. So that's why we have not discussed here, but in the competitive they have given, and what is that reaction is carbide amine reaction. Very important for the PU examination also. Clear? So what it is here? Carbide amine reaction. So what is carbide amine reaction? Whenever primary amines, very important here, which amines here? Primary amines we have to take, and treated this primary amines with chloroform and alkali. Alkali means I will take here base. Clear? Then we will get the compound is here, and I will write primary amines means I will write here isocyanates. Isocyanates. These are the product. Clear? And you know it gives very offensive smell, very bad smell. So by that we can, by using this smell, we can identify this reaction. And this is isocyanates can also be called as a carbide amines. This can also be called as carbide amines. Isocyanates can also be called as carbide amines. So that's why we will call this reaction as a carbide amine reaction. Here, so what it is here? Suppose I will write here R and H2. So NH2 is there, it is a primary amine. Which amine it is? Primary amine. And treated with the chloroform, you already know what is the chloroform for CH, Cl3, and alkali. Alkali means you have to write here base. Clear? Isocyanate, you know already what is the functional group in the cyanide? Cl is the functional group. Clear? Isocyanate means what is the functional group? NC. Cn is cyanide, NC is isocyanate. Means you have to get in this reaction isocyanates. So that's why plus. See here, nitrogen is there here, carbon and nitrogen combined, R and C. Then what is there here? Potassium and chlorine is there. Will be removed as a KCl. Will be removed as a which one? Potassium and chlorine. Chlorine will be removed as a KCl. And now here OH is there and here hydrogens are there. H and OH. What you will get? Water. Now balance the equation. Clear? And you know that here chlorines how many are there? 3. But here in the product sides chlorines how many are there? 1. So multiply this one with the 3. So then here how many potassiums are there? 3. But here in the reactant side only 1. So multiply this one with the 3. Clear? Now you see. And 3 KCl and here also 3 potassiums and here also 3 chlorines. Next balance here hydrogen and oxygen atoms. Here how many OHs are there? 3. And here H and here H. How many hydrogens are there here? 2. And here 1. 3 hydrogens and 3 OH. You will get the 3H. This is we will call as a carbide amine reaction. What the product you will get here? Isocyanide. Clear? And it gives very offensive smell. So by this smell we can identify this reaction is a carbide amine reaction. So this is carbide amine reaction. Then what they are asking, when chloroform is treated with amine and KOH, and we get what it is, isocyanates, but they have not given here. They have given rose odor smell, sour almond like smell, offensive odor, source of oil of wintergreen like smell. So what is the smell you will get here? Offensive smell. So your option is option 3 is the correct. Remember this one, very important, and also so many questions, 3-4 questions they have given based on this carbide amine reaction. Clear? Next one. Coming to the question number 7. See the question number 7. A mixture of 2 organic chlorine compounds was treated with sodium. 2 organic compounds. Let those organic compounds are A and B are treated with sodium. Are treated with which one? Sodium in dry ether. In dry ether. Then isobutane was obtained as a product. Isobutane. What is the isobutane? CH3, CH3. You know, CH3, CH3. This group we will call as a iso. Butane means how many carbons should be there? 4. So that's why this is the isobutane. This is isobutane. Clear? Now what they are asking you, see, the 2 chlorine compounds are. These are 2 organic chlorine compounds. What are those? A and B they are asking. Clear? Simple. I already mentioned. Alkyl halides treated with which one? Sodium in dry ether. Which reaction it is? It is a Wurtz reaction. It is a which reaction? Wurtz reaction. So you already know that in the Wurtz reaction we have to take the 2 halogen organic compounds. So now if you see in this one, if I break here, then what I will get? Isopropyl and methyl. Take that one only. CH3 and CH and CH3, and if I take here chlorine, isopropyl chloride. Another one, what it is there? Methyl chloride. CH3Cl. Or simply I will write here CH3Cl. And in the presence of which one, my dear? Sodium. Clear? You know that. And remove here NaCl. 2 Na and 2 Cl, we will get the 2 NaCl. So next one, what it is there? Here isopropyl group is there and here which group is there? Methyl group combined, then what you will get? CH3, CH3, and here you will get CH3. So that's why, what are those 2 organic halides here? One is isopropyl chloride. One is what it is, isopropyl chloride. And another one should be, what it is here? Methyl chloride. If you take here, methyl chloride. And these 2, when I treated with the sodium in dry ether, I will get the compound is isobutane. So your option is here. Option 3 is the correct one. Okay? And next one, question number 8. Alkyl halides can be converted into Grignard reagent by, this is preparation of Grignard reagent. We have already discussed in the BU part how to prepare the Grignard reagent. Take the alkyl halide, treat this one with the magnesium in presence of which one? Dry ether. I already mentioned why we have to use the dry ether in this reaction also. So what we will get? RMgX. We will call this one as a, Grignard reagent. This we will call as which one? Grignard reagent. So how to prepare this? And they have given options here. Warming them with a magnesium powder in dry ether. Warming them means what it is? Alkyl halide. So alkyl halides warmed with the magnesium powder in dry ether, you will get the Grignard reagent. Your option is, option 2 is the correct one. Yeah, next one is, see the question number 9. And based on it is also related to the Grignard reagent only. So which is not present in Grignard reagent? You already know what is the Grignard reagent. RMgX we will call as a Grignard reagent. Clear? What is R here? R is a alkyl group. R is a alkyl group. Clear? And magnesium is a metal. Magnesium is metal. And what about the X? X is here. Halogen. X is here which one? Halogen. Yeah? So now they are asking which is not present in Grignard reagent. One is, first one, methyl group. Methyl group means what it is? Alkyl group. Next one is magnesium. Magnesium is present. And another one is halogen. Halogen also present. Fourth one, alcoholic group. Alcoholic group means what it is? OH group. Is there any OH group in the Grignard reagent? No. So that's why your option is, which is not present they are asking. So that's why option 4 is the correct one. Coming to the next question. The reactivity of ethyl chloride is. Reactivity of ethyl chloride. What is the ethyl chloride formula? CH3CH2Cl. And it is comparing with benzyl chloride. What is the benzyl chloride formula? You already know that here. Benzyl. On the benzene ring CH2 is there. Carbon is there. On the benzene ring sp3 carbon we will call as a benzylic carbon. So the benzylic carbon, if chlorine is added, then we will call it as a benzyl chloride. Now we have to compare the reactivity of these two. Clear? You know that alkyl halides involved in the nucleophilic substitution reaction. You know that it is a which alkyl halide? Primary, because chlorine is attached to which group here? CH2. So that's why it is a primary alkyl halide. Clear? And you know that here also chlorine is attached to which one? CH2. CH2 means it is also primary halide. Both are primary halides. And as you know, both are primary halides, then they involved in the SN2 mechanism. When primary halides are there, tertiary alkyl halides and follows the SN1 mechanism, and primary alkyl halides follows SN2 mechanism. They follow which mechanism here? SN2. And when SN2 in the SN2 mechanism, nucleophile attack from the backside. Nucleophile attack takes place from which side here? Back side. Clear? So whenever the nucleophile attack on the carbon from the back side, and here group should be less bulky, then only nucleophile attack takes place easily on this halide. Clear? And compare here CH3. But here which group is very bulky group is there? When bulky groups are attached to the chlorine attached carbon, the nucleophile will not attack easily at the carbon. Clear? So that's why which primary alkyl halides are having less hindered groups, and that alkyl halides shows the high reactivity towards nucleophilic substitution reaction. So it is CH3 group here and here phenyl group. Which one is bulkier? And phenyl is more bulkier. So that's why it won't allow the nucleophile to attack on the chlorine attached carbon. But here as compared to phenyl, CH3 is a less bulkier, so small group, so that's why it allows the OH minus ion to attack on the carbon. So that's why, and ethyl chloride is more reactive than the benzyl chloride. Which reaction? SN2 mechanism. If you take SN1, it is a reverse. Yeah? So that's why your option is, so the reactivity of ethyl chloride is second option, more than that of benzyl chloride. More than that of which one? Of benzyl chloride. It is more reactive, it is less reactive towards SN2 mechanism. Clear? And coming to the next question, 11th question. The reactivity of halogen atom is minimum in options they have given. The first one is propyl chloride. You know what is the formula of propyl chloride? CH3, CH2, CH2, Cl. This is propyl chloride. Propyl iodide. Second option they have given propyl iodide. Propyl iodide means same. Instead of chloride, you have to put the which one? Iodide. Here chlorine and here iodine. Isopropyl chloride. Iso group means you already know. CH3, CH3 group we will call it as a iso, and this is chlorine. This is the third option. Clear? And last one is fourth one. Isopropyl bromide. Isopropyl bromide same. This is iso group, and here which one we have to write here? Bromide. So reactivity of halogen atom is minimum. Yeah. So you know that these all are alkyl halides. Alkyl halides involved in the which reaction? Nucleophilic substitution reaction means nucleophile attack on the carbon and halogens will be removed. And you know that leaving group nature, the reactivity of iodine is good leaving group compared to the bromine and compared to the chlorine and fluorine. Which one is very good leaving group here? Iodine. Yeah, and which one is minimum leaving group? Means good leaving group here, bad leaving group is fluorine, but fluorine not given here. They have given iodine, bromine, and chlorine. They have not given here fluorine. So iodine compounds, iodine can easily remove, but compared to the bromine, but here least reactivity or bad leaving groups are here chlorines only. So that's why they have mentioned here halogen atom. Reactivity of halogen atom is minimum. Is minimum means where these two are maximum reactivity they will show, but these two will show the minimum reactivity. So that's why these two are not the correct options, and these two are in these two you have to choose one correct one. Clear? So what is here? You know that they involved in the this is nucleophile will come here, and here also what will come? Nucleophile. But here you see which group is present here? Ethyl. But here which groups are present? Methyl. Methyl groups are there. You know these methyl groups are more bulkier than the ethyl group. Only one ethyl group is there. But here how many ethyl groups are there? Two. So these ethyl groups, due to its bulkiness, and these two CH3 groups will not allow the OH- ion to attack on this carbon. So that's why chlorine will not leave easily. So it will show in this compound chlorine will show the minimum reactivity. So our option is. Option 3 is the correct one. Just simply you have to see the bulkiness. Where the bulkiness is there, and that molecule will show the less reactivity. So here bulkiness is compared to first one. Second one compound is more bulkier, so that's why it will show the less reactivity towards the nucleophilic substitution reactions. And this is the question number what it is 11. And question number 2. Chlorobenzene is chlorobenzene. You already know that. What is the chlorobenzene? On the benzene ring, there should be a chlorine. This is chlorobenzene. And chlorobenzene is less reactive than the benzyl chloride, more reactive than ethyl chloride. You have to just compare the reactivity of this chlorobenzene from the benzyl chloride. Take the benzyl chloride. What is the benzyl chloride? And just now only we have mentioned benzyl chloride and the CH2Cl. Okay? Compare the reactivity. You know that here chlorine is having lone pair of electrons. In chlorobenzene, lone pair and double bond is separated by single bond. So they are in conjugation. Lone pair and double bond are in conjugation. When they are in conjugation, they are involved in the resonance. When they are involved in the resonance, the single bond is converted into which bond? Double bond. And I already shared. And here the chlorine on the phenyl ring, the bond is not a single bond. It is a partially double bond. So that's why, and this bond to break is very, very difficult. So they are, that's why haloarenes will show the less reactivity towards the nucleophilic substitution reaction. So that's why compared to these two, it is a which bond? Single bond. But here which bond? It is a partial double bond, and to break the double bond is difficult compared to the single bond. So that's why compared to the which one here? Chlorobenzene. So that's why your option is the first option. Option 1 is the correct one. Clear no? So coming to the next question. Question number 13. The reactivity of methyl chloride, propyl chloride, chlorobenzene in the RN. You already know that methyl chloride means what is the formula? CH3Cl. And next one. Another one is propyl chloride. Propyl chloride means CH3, CH2Cl, propyl chloride. Next one is chlorobenzene. What is the reactivity RN? Chlorobenzene. Okay? And compared to these two, and this is less reactive. Why? Because it is a which bond here? Partial double bond. So partial double bond means this chlorine will not be removed easily. So that's why it is compared to these two. It is a very less reactive. So that's why it is least reactive. Now compare these two, and comparing these two, here which group is there? Ethyl group is there. And here which group is there? Shall I write this is CH2H here? Where the nucleophile attack takes place? On this carbon, chlorine attached carbon. Nucleophile will attack here. Nucleophile will attack here. So here, hydrogen is, it is very small group, but ethyl group is a bulkier. As I already said, if any group is there, bulkier group in the alkyl halide, that will show the less reactivity. So here, it is a small group, hydrogen is a small group, and here ethyl is a bigger one. Bigger one means more bulkier. More bulkier means less reactive. So that's why this is the R. Methyl chloride will show the high reactivity compared to the ethyl chloride, and least reactivity is here chlorobenzene. That is the R. So what is your answer here? Now option 1 is the correct one. And coming to the 14th question. Question number 14. See the question number 14. Which of the following compound will make a precipitate most readily by AgNO3? So means AgNO3 is there. So which one of these compounds will give and precipitate readily? You already know options they have given here. CCl3CHO. Clear? And this is we will call as chloral. Chloral. What is the name of this common name of this compound? Chloral. Trichloroacetaldehyde. Second one they have given chloroform CHCl3. And the third option they have given C6H5CH2Cl. And your benzyl chloride. Next one is iodoform. As you already know that precipitate, when you will get the precipitate when Az reacted with the chlorine, you will get the AgCl, and here also AgCl, and here also AgCl, but here you will get AgI. You know that iodine is a very good leaving group, so it will react immediately with the silver. So that's why you know that whenever iodine means iodoform, this is reacted with the AgNO3, you will get the what is the compound here? AgI plus AgI you will get, then CHI2 plus you will get the HNO3. Then simple it is HNO3 minus, and you will get here NO3 minus. So AgI is a what it is? Precipitate, yellow precipitate. But you may ask here, whenever AgNO3 reacts with the chloroform, and here CCl3 and CCl3CHO, and here also chlorine is there. Yes, whenever AgNO3 reacts with the chloroform also, you will get AgCl. But AgCl precipitate will not form. Why? Because it easily compared to AgI, AgCl is more soluble. More soluble means in the solution you will not get any precipitate. So that's why your option is here iodoform. Coming to the next question, 15th question. So it is based upon carbide amine reaction, what I have discussed in the previous. So carbide amine is liberated when gas is heated with chloroform and alcoholic potash. Okay? Carbide amine is liberated. Carbide amines means what? Isocyanates. I already mentioned isocyanates can also be called as a carbide amines. So they are mentioned here. Carbide amine is liberated when which compound is heated with chloroform and alcoholic acid. I already mentioned very clearly, whenever primary amine reacted with chloroform and alkali, then what the compound you will get? You will get the isocyanide, and can also be called as a carbide amines. Can also be called as a which one here? Carbide amines. Okay, so that's why. And what is reacting with the chloroform and KOH here? Primary amines. So this is the answer. Clear? So what they have given, first one is an aldehyde, second one is the primary amine, third one is secondary amine, and fourth one is phenol. Remember, and only primary amines will give this reaction. So this reaction can also be used to distinguish the primary amine from the secondary and tertiary amine. Tertiary and secondary amines will not react with the chloroform and KOH to give isocyanates. Yeah? So that's why your option is here primary amines. So option 2 is the correct one. Next question. Question number 16. Salicylic acid can be prepared using Rhinoprimal reaction by treating phenol with. And we have already discussed about the Rhinoprimal reaction. Clear? So what is the Rhinoprimal reaction? Rhinoprimal reaction, where we have discussed this reaction in alcohol, phenols and ethers. There we have discussed. What is the reaction here? Whenever phenol reacting with the chloroform, what it is here? Chloroform plus NaOH, that is a base. What the compound you will get here? You will get the compound is salicylic acid, salicylaldehyde, not acid here, aldehyde. This is the compound. But what they are asking here, salicylic acid to prepare. So now what you have to take, and here phenol should be reacted with CCl4. Should be reacted with which one here? CCl4. You already know how this reaction takes place. Phenol means first it will react with the NaOH, and phenol react with the phenol is an acid and NaOH is a base. You will get the which one here? Salt. That is an. So you know that CCl4, carbon, and how many chlorine atoms will be there here? 3 chlorine atoms. Now, when this bond comes, this will attack on the carbon, one of the chlorine will be removed. Then what the compound you will get? You will get the compound is, so here there will be a double bond because here bond formation takes place. Double bond and carbon. How many chlorine atoms are there here? 3 chlorine atoms are there. Clear? Now, in this one, there will be a one hydrogen. Because it is not a benzene ring, because it is a benzene ring. You know the benzene ring is there, the molecule gets the stability. But here there is no benzene ring, so that's why it is unstable. To get the stability, again this ring converted into the benzene ring, so this bond will go towards the oxygen. Oxygen is gaining electrons, so that's why you will get the compound is, this is the compound. And OH is present here, and carbon, chlorine, and chlorine. 3 chlorine atoms. And the next one, we will treat this one with the which one? NaOH. So here how many chlorine atoms are there? 3. I have to take here 3 moles of NaOH. Each chlorine is replaced by the, each chlorine here. Here it will be converted to Na, because again we are treating with the NaOH, phenol, and it is converted to sodium phenoxide, and all these chlorine atoms are replaced by OH. Already it is substitution reaction. As I already mentioned, if 2 OH groups are present on the same carbon, the molecule is unstable. But here how many are there? 3. So become very, very unstable. So it will be removed. When water molecule is removed, then what the compound you will get? You will get the compound is ONA, and here what is there? C double bond O will come, and here one OH group is there. OH. What is this? Acid. Now treat this one. Actually, sodium is there, NaOH is there, you will get sodium. Then hydrolysis you do, then what the compound you will get? You will get the compound is here OH and here C double bond O, OH. So what it is, this is? This is salicylic acid. So to get a salicylic acid, we have to treat the phenol with which compound here? CCl4. CCl4 means what it is? Carbon tetrachloride. To get a salicylaldehyde, you have to treat the phenol with which one? Chloroform. That is the okay. So this is phenol treated with chloroform, you will get the salicylaldehyde. But phenol treated with carbon tetrachloride, you will get the salicylic acid. So your option is here. Option 3 is the correct one. phenol salicylic acid can be prepared by using Rhinoprimal reaction by treating the phenol with carbon tetrachloride and sodium hydroxide. So here option 3 is the correct one. And next one, question number 17. Clear? Grignard reagent is prepared by the reaction between. We have already discussed how to prepare the Grignard reagent. How to prepare Grignard reagent? We will take the alkyl halides is treated with the magnesium powder in the presence of dry ether. Then you will get the Grignard reagent RMGX. So, and magnesium and alkyl halide, option 2 is the correct one. Next one, 18th question. Question number 18. So 18th question, reaction of tertiary butyl bromide with sodium methoxide produces. So we have already discussed this one also in the class 1, and PU, in the PU part we have discussed already this is. And the tertiary butyl bromide they have given here, tertiary butyl bromide, and treated with the sodium ethoxide. Sodium methoxide they have given. What is the sodium methoxide formula? This is sodium methoxide, CH3ONA. Clear? Sodium methoxide and produces. And which compound will be produced? Clear? And you know that this is a tertiary alkyl halide, and this will be converted into Na plus. Metal always positive. Metal positive means oxygen will be negative. Here tertiary alkyl halide is there, and also here which one is there? CH3O minus. CH3O minus is a strong nucleophile as well as strong base. It can act as a strong nucleophile and can also act as a strong base. Clear? And you know that when the nucleophile is strong, then which reaction takes place? SN2. I already mentioned. Base is strong, the reaction is a SN2. Clear? And here, base is here, nucleophile is strong. It is SN2. This reaction follows which mechanism? SN2. But you know that in the SN2 reaction, only primary alkyl halides are involved. But here which one is involved here? Tertiary alkyl halides. So that's why it won't involve in any nucleophilic substitution reaction. Got my point here? You know that here strong nucleophile is there. Whenever strong nucleophile is there, the reaction follows which mechanism? SN2 mechanism. To follow the SN2 mechanism, the alkyl halide should be which alkyl halide? Primary alkyl halide. But what is the alkyl halide they have given here? Tertiary alkyl halide. So that's why here there is no substitution reaction. So that's why you know that here the nucleophile can also act as a base. Base means which reaction takes place here? Elimination. Clear? So that's why. And CH2H and here HBr will be removed. Clear? Then what the compound you will get? CH3 and CH2 double bond, and here CH3 plus what you will get over here? HB. Clear? So now what is the name of this compound? And you know this is a alkene. Alkene means what it is? 1, 2, 3. 2-methyl, propene. That is, you can write here answer is isobutylene also. Because CH3, this is iso. So isobutylene. This is the answer. Simple. It is a strong base, and so that's why the reaction is a elimination reaction. So coming to the question number 19. War gas is formed from, war gas. War gas means I already mentioned here. One is first previous I have mentioned phosgene, and here also chloropicrin. What it is my here? Chloropicrin. What is the chloropicrin formula? CCl3 NO2. This is chloropicrin. Clear? So trichloro nitromethane. This will be called as trichloro nitromethane. This is also can also be called as tear gas. Can also be called as which one here? Tear gas. So it is also used in the World War I. So this is phosgene and also tear gas. Yeah? And so your option is option 4. So next one. Coming to the question number 20. The bad smelling substance formed by the action of alcoholic caustic potash. Alcoholic caustic potash means what it is now? KOH. Clear? On chloroform and aniline is. Clear? So what they are asking here, aniline. You know what is the formula of aniline? aniline is NH2. On the benzene ring NH2 is there. That compound we will call as a aniline. Aniline is treated with which compound here? Chloroform. And another one they have mentioned here, alcoholic caustic potash. What is that one? KOH. What is this reaction? You know, primary amines, chloroform, KOH. What is this reaction? Carbylamine reaction. So what is the compound you will get here? You will get the compound is isocyanide, NC. Plus what you will get? 3 moles of KCl and 3 moles of water. So what we will get here? Phenyl isocyanide. This we will call as phenyl isocyanide. Clear? So these are the, I already said isocyanides are gives the offensive smell. So that's why bad smell means what is the compound formed here? Phenyl isocyanide. Next one. Coming to the question number 21. Ethylene chloride on treated with aqueous KOH. I already mentioned ethylene chloride means gem dihalides. Clear? So ethylene chloride means CH3, CH, Cl and Cl. This can also be called as gem dihalides. Or can be called as, you know, ethylene chloride on treated with aqueous KOH. Aqueous KOH. You know that? I already mentioned in the previous. Whenever there is a aqueous KOH, substitution reaction. Whenever there is alcoholic KOH, elimination reaction. So aqueous KOH means what it means? Substitution, and chlorines will be substituted by the nucleophile, that is OH. So what you will get? 2 moles I have to take here. Then I will get CH3CH and OH and OH. Clear? And 2 moles if I take here, minus 2 KCl will be removed. Take here 2 moles, no problem. Then 2 moles of KCl will be removed, and here OH is replaced with these 2 chlorine atoms, and you will get the 2 OH groups here. As I already mentioned previous, and whenever 2 OH groups are present on the same carbon, you know that here OH groups are, you know, oxygen is having lone pair of electrons, and this oxygen is also having lone pair of electrons. Due to the lone pair repulsions, this molecule become unstable. To avoid that repulsions, one of the oxygen will be removed in the form of water. H and OH. When elimination reaction takes place, you know, double bond will be formed here. CH3 and CH double bond O. So this we will call as a acetaldehyde. Acetaldehyde. Clear? So your option is option which one here? 2. Option 2 is the correct one. And next one is question number 22. So question number 22, what they have given? C2H5I plus C5H11I. C5H11I is treated with 2 moles of sodium. 2 moles of sodium. Then it gives C2H5 and C5H11 plus 2NaI. What is the reaction? I already mentioned. Whenever alkyl halides and sodium is there, which reaction it is? Wood reaction. So your option is here. Option 3 is the correct one. Clear? Next one. 23. In the presence of AlCl3, benzene and N-propyl bromide react in Friedel-Crafts reaction to form. Very important question this is. Clear? So many times this question is asking in the examination. Benzene and N-propyl chloride. This is the benzene and treated with which one? N-propyl chloride. N-propyl chloride means CH3, CH2, CH2, Cl. This is propyl. 3 carbon atoms are there, propyl, and chlorine is there, propyl chloride. And what is AlCl? What is the product they are asking? Yeah. So you know that it is a Friedel-Crafts alkylation. Friedel-Crafts alkylation. What is the intermediate here? Carbocation is the intermediate. We have already studied in the first year. What is the carbocation will be formed here? You know, chlorine and carbon. Carbon, chlorine if you compare. Chlorine is more electronegative. More electronegative means it takes the electrons towards it. Which one is gaining electron here? Chlorine is gaining electron, carbon is losing electron. Losing electron means which charge it acquires? Positive charge. So that's why positive charge here, and plus there will be a Cl minus. Chlorine is gaining electron, acquires negative charge. Clear? And as I already mentioned in the previous, whenever there is a carbocation is intermediate, if there is a chance they involved in the rearrangement. So it is a which carbocation here? Primary carbocation. And you know that here one of the hydrogen, it moves along with its bond electrons to here. Along with bond electrons means hydrogen gets which charge? Negative charge. Carbon is having which charge? Positive. Negative and positive means what happens? Bond formation. So you will get the compound here is CH3, CH plus, because hydrogen is minus, carbon will be plus, and you will get the CH3. Which carbocation? This is primary carbocation. This carbocation is secondary. So which carbocation is more stable? As you already know, secondary carbocation is more stable than the primary carbocation, so that rearrangement takes place. Clear? So due to here primary carbocation is less stable. To convert into secondary carbocation, the rearrangement has been taken place here. Clear? So that's why. What is the compound now you will get to see? In this one, benzene is there. Now benzene reacted with which compound here? Secondary carbocation, that is CH3. Then you know electrophilic substitution reaction. So you will get the compound is, what the compound you will get? CH, and here CH3 and CH3. So what we will call here? Isopropyl benzene. So what is your answer? Answer 4. What is the name of this compound? Isopropyl. CH3, CH3. What we will call this group? CH3, CH, CH3. This is iso group. This is which group? Iso. But how many carbons are there? 3. So what we will call? Isopropyl benzene. Benzene is there? Benzene. Isopropyl. What we will call here? Benzene. So this is your answer. So option, which one is here? Option 4 is the correct one. Clear? And coming to the next question, 24. Question number 24. What they have given here? That dehydrobromination of 2-bromobutene gives. 2-bromobutene. What is that 2-bromobutene? Butane means what it is? How many carbons should be present here? There should be 4 carbons. 2-bromo means some of the second carbon, which one should be present? Bromine. Clear? And it is converted into, it gives the compound is CH3 and CH double bond and CH3. This is we will call as dehydrobromination. Means here hydrogen. Shall I write here CH2 as a CH and H? Then remove H and Br, and you will get minus HBr, and you will get the double bond here, because elimination reaction single bond is converted to which bond? Double bond. This is. So they are asking, and this is formed, and the product is which product? You know that it is a always elimination follows the Sage-Joff rule. So that's why, and this product we will call as a Sage-Joff's product. Clear? So this is which product here? Sage-Joff product. So what is here? Option 2 is the correct one. And next one. Coming to the question number 25. Ethylene difluoride. What is the ethylene difluoride formula? CH2, CH2 and fluorine and fluorine. This is ethylene difluoride. 2 fluorine atoms are there. On hydrolysis. On hydrolysis means what it is? H2O, add water. Whenever we add water, you already know 1 H and 1 F will be removed as a HF. Take the 2 moles here. So what I can write up water here? H and OH. Take the 2 moles H and OH. And here 1 H and 1 F will be removed as a HF. And here 1 H and 1 F will be removed as a HF. So which one will be left here? OH. OH will be added here. Then what the compound you will get is here CH2, CH2. Instead of fluorines, what you will get? OH and OH. What we will call this compound? Ethylene glycol. So what is your option now here? Glycol. Simply we can say glycol. So option 1 is the